Hello and welcome back to another episode of
Human Resource Machine.
That's right.
Hello. So we are at level 40 and we are doing this prime factory, whatever that is. Well, last time we haven't, wow, what is this?
Wow.
Oh my god. No, we are not doing this again. We're just going through the code, right?
We're not doing it again, we're just going through the code.
That's too much.
Because we did it all and we did not record.
Well, we did record it, but the sound didn't work.
Yeah, the sound didn't work.
Okay, and we haven't finished challenges. I've seen.
Oh yeah.
Yeah, so maybe we can optimize.
Oh, let's see.
Okay.
So
what is the goal here? For each thing in the inbox, send its prime factors to the outbox in order from smallest to largest. Okay, so these are the prime factors.
These are prime numbers. We just set up the prime numbers. That's the first thing. Like the first 32 statements are just set up the prime numbers. That's just set up, right?
Yeah.
And we just set up all the prime numbers up to 37.
So that's 32 steps already.
Yeah. And now it just goes in for division, I think. 17, it checks if it can divide by 1. Which is ludicrous, because 1 is always a prime factor, so there's an optimization. Yeah, but we could just go through everything. It runs forever. I'm so impressed. Yeah, it just runs forever.
There are 3 other persons in the room.
No, but we're skipping one, I think. Don't we? Oh, we just... No, we use the 1 to set up, like, something. Oh, 17 is prime.
Yes.
That's the thing. 17 is prime. 2 is a prime factor.
Are we checking 18 already? No.
Yeah, I think we're doing the previous one. We don't know which one it is. But it has a lot of 2's. Now we're doing 18. 18 is 2, 3, 3, right?
Yes.
Yeah, it's just division, essentially. And sequence, that's like... That's a thing... I think that's storing the currently number under investigation, right?
Mm-hmm.
Yeah, and one is not in the outbox. Prime factor, size challenge. Yeah, it's a huge size. There's probably a better way to do it.
Speed 2.
Okay, right. I think we just lost our mind with that one. So let's just go through it and explain how the program works.
Yes. Well, first things first, we have to set up the prime numbers.
Yeah, we need
AKA the prime factors of the inbox numbers.
Oh yeah.
Okay. So we copy from 0, which is a 0.
Which is a 0.
And copy to tile number 1.
Yeah, which is not, we should not contain a 0, but now contains a 0, right?
Okay, and then we bump the tile number 1, or the value in tile number 1.
Yeah.
So that we get the number 1.
Yeah, so now there's the number 1 in it, yeah.
And we so we have the number 1 in hand and copy it to tile number 2.
Yeah.
And bump this
the value.
very tile and have a number 2.
Right, and we also have that in hand, the 2, that is.
And then we add 1.
Yeah, because tile 1 now has the number 1, and we we don't have anything on the floor right now, we have the 3 in hand. That's why we copy to 3.
Okay.
Then we add the value 2, which makes it a 5.
Maybe we run 1.
Oh yeah, just step through it. I mean, it's the setup.
Okay. Copy from 1, that's copy from 0 to 0, put it on the floor bar, that's good.
Oh yeah, you can step through it if you click on step.
Oh.
And then it does 1 step. Oh, now you can't see. Okay. But yeah, if you only click on that, it also, when it runs and you click that, it does 1 more step and stops. So if you press play and then press this button, then it just stops. And that's how you make it pause.
Okay,
Yeah.
that's better.
Okay,
we
so
bump the value to get 1, put it to copy to file number 2. Bump again, so that you have 2 in that file. You have 2 in hand. Add the value in tile 1, or is it add 1? No, add the value.
It's all the value in the tile called 1.
Okay, then you have a 3.
But we kind of named it to be the value also that will end up in the in there.
Okay. Put it to 3. Do we have to? Well, do we have to have all these?
Well, we're filling them all up.
Okay.
Yeah, I think the biggest number that shows up is actually 37. Or yeah, so we actually do need it.
Okay. Okay, copy 5 to tile number 5.
We have a 7 now.
Copy to tile number 7 at 3.
And the static setup does not have a huge impact on the overall performance.
That's all those circles jumping we put in.
Yeah, it's all the jumping.
Okay. Okay, so 11. 2 again. Well, 2 twos.
I think you can just go through the setup. It's just adding values and then storing them again.
Yeah.
I think we go from smallest to biggest value. And maybe we can switch that around and go from biggest to smallest value, because the smaller ones they kind of divide. If you divide 18 by 2, you get 9, which means that to do that we have to run through there 9 times. If you divide it by the 9 then by 3, you have to run 3 additional times, so that's 12. And then for the final 3, I think you run it once again, so that's 13. If you go from big to small, run the 3 first. 18 by 3 is only 6. And then you would go for another 3, that's 7. And then you go for the 2, that's 8. So instead of running 13 times, you would run 8 times. So we would be faster that way, but we would have to start with the biggest prime that we have, which is 37. I think we can do that.
But what happens if it's too big and you cannot divide through it? Do we have a error?
Yeah. So all of them. No, I think we're good.
Okay.
Yeah, there would certainly be numbers that would break us, but they are not part of our input set, so we don't have to worry about them. We only worry about things that are actually in our input.
Okay, so your suggestion starts here. We have to change something here already.
Yeah, let's do that in another tab though, because I kind of want to. So let's just run through this, see how this actually works, so we remember. Then copy all of that to another tab, so we have a copied version, and work on the copy.
Okay.
If you want to give up, then we can. I still did not lose anything.
So copy from 1. What do we do? Copy to I.
Because that's
That's the index one.
That's index 1, I guess so. Copy from 0, copy to R. Don't know what R is. Okay, the inbox is like, this is now the sequence, the number that we're currently checking. I think that was, we call it the sequence or something. Okay, so this is what we're currently checking, and what we're checking is also the temporary. The temporary is where we do the division.
Okay. Here.
Right. There are several reasons to get up here. Okay, so we copy from the sequence, so that's what we're currently investigating. We subtract 1. I don't know why.
Are we subtracting 1 or...
okay.
Just to make sure that the lower prime numbers aren't indicated.
Yeah, no, we do that so we can skip the 1. If it's 1, we don't look at it. We're checking if the number is now 1.
Because the 1 is always in there.
Yeah, the 1's always in there, and yeah, because it explains itself with the next step, a jump of 0. If 0, then we go to the, wait, what's it doing if it's 0? Yeah, okay, we get the next, we reset and get the next value, because we're done. If that one's 0, we're done. Okay. But it is not 0, because we just started. Copy from T. So this is the, okay, this is the current,
This is the...
a current subset somehow.
This is the actual number we are... Oh no, this is temporary number.
Yeah.
Subtract
I, and this is where we would have to go in there, and that's the thing that we would have to change the I, because index I is now pointing to, yeah, it's pointing to 2. See,
Is it pointed to not
the
to
value
1?
2. Yeah, it's pointing to index 1, which is the value 2.
So the tile, this tile is 0.
That's the tile is 0. The index of the tile is 0. Yeah.
Okay, I didn't see that.
Okay, it's not negative. We're not done with dividing.
Jump is 0. It's not 0 either.
Yeah, negative and 0 I think are the same thing. No, it's not. Okay.
So it's not, and we copy to temporary.
Okay.
Bomb. R.
Yeah, because you successfully divided. Okay.
Jump. Okay, now we are jumping.
Okay.
What are we jumping to though? Okay, so we do the sequence again.
Why? Okay.
Copy from.
Yeah, that seems unnecessary. Okay.
We have a 1 in hand.
No, but we're copying from the sequence. We're checking if the sequence is 1. We're checking that again. I don't think we have to check that every time. So that might
This
be...
is the second. This is the same process.
That's the same process, yeah. But now we're starting with a T of 2.
Oh, okay.
That's probably that was our thinking, like do the same process, just don't bother too much. But yeah, definitely something that we can optimize here.
So we go there again.
Okay, it's not negative, but it's 0, so we're done with checking that. Okay.
Okay, then we jump down. It's 0, so we jump all the way down here.
Yeah.
And bump R.
We bump R. And we found a prime. Yeah, that's the division that we did was with a prime. Okay. Copy from I. So this is the prime that we found, which you also have in hand, and I think that's always true. I'm not sure. Okay. Copy to outbox. So this is the prime we found. Copy from R. So R, yeah. R is our remainder. And now the next number that we're looking at is R. Or not remainder, you know what I mean, right? Copy from 0, copy to R. now we're going and try for... Okay, we're looking if the sequence is now 0, which it isn't, and so that's why we divide again. Okay. There's a not prime part. Yeah. And that is if the prime we're looking at is not, if that is not a prime of it. So we won't see that for this value. But I guess we'll see it for 14, right? If we go to 14. So 14 by 2, that'll check out. But 14 by 3 won't. And it's running to the 1 all the time. We were very paranoid about that. Okay, now with the 7, we're checking if 7 can be divided, and that is not true at some point. So it'll be negative at some point. Because it does not cleanly divide. Yeah, so that's negative. No, it isn't. Oh yeah, it was negative, and it's not prime, so that's why we reset everything and start. Yeah, that's why we had the sequence value. The sequence value helped us to reset if R was not correct. Okay. So let's copy that and paste it in here. So the one thing we noticed was that we are like checking this all the time, and we don't need to. We need to check it for the other two cases. We don't have to check it for these two. So I guess this will also works. Let's have it run. Just not check all the time. Yeah, looks good. Did not crash yet. And we removed a check for 1. And it does not loop indefinitely. Okay. And the next thing I'd like to change is how we work with I. And we need to look at everything that concerns I. So we copy from 1. But actually we want to copy 14, right? So let's set up a 14 for us.
14?
Oh no, you're right, 12. Because that's the index of our highest value.
Yes. Mm-hmm.
So we'll get a 12 in here. Copy from 13, subtract 1, and that'll be copy to... Wait, no. When do we write 13? Yeah, see it's 11. So we add 1. Now we have 12. We copy that to 12. And then we add another 1, and then we have 13. So that's probably the least invasive thing to do. You write the 12 in between here. So now we don't want to copy from 1. We want to copy from 12, copy that to I. Subtract I, is that... yeah, that's okay. We bump plus the I, that's no longer true. The command we use is bump minus on I. Copy from I is still correct. Where do we reset? Oh, we reset if we found a prime. We reset and try to find the next prime. Okay. And only if we don't find the prime, we go to... Okay, I have no idea if this just works. But we kind of flip the direction in which I counts, which should be okay. Okay, there's a lot of one-time checks. Because it has to go through all the primes and see that it's actually not that prime. You output a... Oh! Okay. No, management expects an order. They expect us to output the other prime first, so that doesn't work.
Ah, from the smaller to
yeah.
bigger side.
So let's flip that. And this bump plus now. And we don't copy from 12, we copy from 1 again. And also we don't need to create the 12 in the first place. So this one's add 2 now. Remove that. Anything else we're doing with I? No. Okay, so that didn't work. But we saved the bit. I don't know how we get this to run faster. I mean, we saved a lot of checks, but I don't know if that's hundreds of checks, because we were off by 1 or 200, I think. I mean, it's running a lot of times, and we removed a lot of checks because each of these steps would have had a check.
Yeah, the problem is we have to go through every prime factor, so that takes a lot of time.
Yeah, can we skip? Is there some way for us to skip prime factors?
But if we know that the number we're taking from the inbox is already bigger than...
Well, every prime factor is smaller than the number.
Yeah. I know what you mean. Oh yeah, actually we have...
Yeah, it's
the
a lot.
speed challenge we have gotten better.
Yeah, by a landslide, but not good enough. So we still would have to find like 1 or 2 statements to kick.
Mm-hmm.
So this check is necessary, I think. Let's step through it and, well, maybe let's get through the setup first. Okay, so we copy from 1. Okay, so now we have the inbox. Yeah, we don't have to copy from sequence here, because we have it in hand, right?
The first time.
Yeah.
Yes.
So where are they coming from?
But do we have to do the setup all over again every time we have a new number?
This setup here.
Yes.
I'm not sure if every step of the setup is required. Copy from 1, copy to I, because we have to start with the first prime again. Or do we? Actually, we don't have to start from the first prime again.
Yeah, because
we can start from the last prime we found, because we know that everything below that was 0.
Was checked already.
Yeah, it was checked already. So we don't need to start from the first prime.
Yes. We only need to start from the second. But from that one we didn't check.
So this is... we have a start, right? And the first thing we do is we copy from 1. Oh no, this is the setup for the inbox. Yeah, that's the setup for the inbox. But we copy from 1 and copy 2. start. And we'll also copy this down to I, which is correct for the first value we check for the inbox. We have to start with 2. But every time we now copy 2I,
Copy from
bump I. No, we do that already. And we do that by bumping or not bumping I. Where did I? Here. Yeah, so if we found a prime, we don't bump I. Only if we did not find a prime, we bump I. So we're going from lowest to highest without repeating, without unnecessarily. So sadly, we already handled that. Copy from, copy to. I'm just reading what the statements right now. Okay, so
do we want to jump through it step by step so we can see what is repeating too much?
This copy sequence, that's because we have it in hand here. We don't need to copy it.
Do we have it in hand?
Yeah, but if you come from up here, I don't know if you have it in hand if you come from down here. Copy to sequence, copy from, yeah, if we wait, copy from R, that to sequence, copy from 0, put that, so we have to copy R first and then reset R. Yeah, if you copy from sequence down here, and probably also in the other case, so we can remove that. In the other case, we also insert a copy from sequence. We have a statement more, but we have less execution. I think we're at 425, right?
Yes,
something like that. Don't know how big the impact of that is. It's probably only like 4. Because it's only relevant when we restart completely. So it's 421 or something. It's okay. But it's a bit, that's a little bit, and we're not missing a lot.
Well, you jumped to 2 to 3 times now.
You jumped to 2 or 3 times now, okay.
Yeah, why is that? Shouldn't it be going through the prime numbers only one time?
Yeah, well, he has to subtract multiple times, right? 422, okay. Yeah, maybe because I think we write down R. Why do we do that? Okay, let's see. God, the setup. This takes ages. Okay.
R is the remainder. If it's negative, we know that we are under 0.
Yeah, but why do we write it down? I guess because the sequence, yeah, because that's the next sequence. If we found something, that's the next starting value, right? That's why you write it down.
I don't know.
Copy to R. Okay. Okay, so we subtract I now. If negative, if 0. Copy to T. And then we bump R. Copy from T, because we just bumped R, right?
Copy from T, yes. And subtract.
This check right here, the subtract 1 check.
Yeah.
That's just strange. Okay, copy to T, bump R, copy from T, subtract 2 negative checks, then copy to T. So if we can do something to this loop, that would have a huge impact. Because we're running through there like loads of times. If you can make it by 1 statement faster, we crack the challenge. Copy to T, bump R.
And then copy
from T again. Because we have to, we're bumping, copy to T. Now we have the subtract value. We're copying it to T.
But if we bump R, we already have the value in hand.
No, it's a different value. That was just randomly because it was 4.
Well, this is 5.
Yeah.
And then we copy from T.
Which is 2. Now it's 0. We found the prime number. We go down here. Because we found the prime number, we bump R again.
God.
We copy from I. Oh, we copy the prime number. Isn't that in T though? Is that always in T?
The prime number?
Yeah, that's always in T. Wait. So we subtracted bump R, but we don't have, yeah, okay, we don't have anything. We bump R, we copy from here, outbox that. Oh, we can bump R later.
Later.
If we bump R exactly here, we have the bumped value. That's 1 statement, I think. After the outbox. Yeah, so I think that should also work and be 1 statement faster for each output, which is a lot. That's actually a lot. It's a lot of prime factors. It could be like 10 or so. So 422 was our statements right now. So we could get down to 410 or something. Let's see. It seems to work. We should take another look at every time we pick up R. If we can solve that by bumping something, by bumping an R. If we copy from R, we should check if we can't bump it. If we can bump R instead.
Well, but actually the video is quite long already and we're running out of
Really?
time. Yes.
But I want to crack the challenge.
Yeah, sure, you can make another video. Because...
Nah, if we finish this video, I'm done with the level.
Yes, because I have to study also.
Oh, I see. Well, we cracked a size challenge, right?
Oh.
It's about 10 statements.
60. It's okay.
So 70 more. If you have a good tip on how to do that, I'd love to know. I'd love to hear. So thank you for watching, and yeah, give us a tip of what we missed in the comments below.
Yeah, bye.
Bye.